Perfect. Okay, so let's start this activity. Good afternoon, everyone. It is a pleasure for me to welcome you to a new webinar of the Spanish technology platform of disruptive technologies, also called Disruptive. Okay, sorry for that. We focus this time in the use cases related to AI. My name is Elena Garcia Mendoza. I'm the project at Network Coordinator of Association of Science and Technology Parks in Spain, also called APTE, which is in charge of the Disruptive platform and is financed by the Ministry of Science, Innovation and University through their State Research Agency. This webinar is organized in collaboration of Wista, Management, Berlin, Adlershof. And our goal today here is to shed light to innovative applications of disruptive technologies in today's world. Our focus is going to be in various fields, and what it usually comes in various fields like quantum technology, blockchain, cybersecurity, 5G, big data, and artificial intelligence. And this time we're going to explain and we're going to focus in this last topic. So we are delighted to count with two of the most distinguished companies related to the Wista Park, and they will present to us in a span of 20 minutes their experience in development utilizing these transformative technologies. After their presentation of the speakers, we're going to have a small round of questions so you can ask any doubts that you can have during this webinar. So before I start with all these explanations, let's start with a few words with Rawad Chamas, who is Knowledge and Technology Transfer Manager of Wista Science and Technology Park, and who is going to introduce the activity. So Rawad, whenever you want.
Thank you, Elena. So good morning, everyone, and hello to this webinar, the first from us in collaboration with APTE. We are very happy to go into this collaboration and open to the Spanish market. As we know, many of our companies are very interested from different fields in the Spanish market. So as Elena said, I'm Rawad. I'm head of knowledge and technology transfer. What I do is I work on the interconnection between the companies and the research activities on our campus and in Berlin. Because Wista Management has developed and managed the Adlershof Science and Technology Park, but also works on different innovation locations in Berlin. One of them, our two brilliant startups are coming from today, and one of our innovation center in the city center. And I am very happy to be here and kick off this collaboration with APTE with such format, and looking forward for many more. I won't take many more time from our guests, our speakers, so I would give the floor directly to the first speaker. And I'm also excited to see what's new with our two startups.
Well, thank you so much, Rawad, for introducing us to this wonderful topic. Yeah, let's now begin our journey of discovering our first AI use cases. It was expected to be here, Philip from Combotics, but unfortunately he's not able to be here with us. But instead, we can count with Vincent Werner, who is working in the development team for the robot of Combotics. So Vincent, whenever you want.
Yeah, thank you. 1 second. I will try to show the screen. This is this, I think. Okay, can you see this?
We can see perfectly.
Yes.
Okay, great. Yeah, sorry, I had a bit of technical difficulties earlier. So yeah, we are. I'm here from Combotics. We basically build construction robots. And the basic idea is, specifically in Germany, but also in other countries, I assume, we have a shortage of skilled labor, right? Like, there's not many people that really want to go into the market to become a painter. And you notice this specifically in Germany if you search for any construction worker or specifically painters to do a job for you, to paint a room, and you would just have hard times finding them. And so basically, this shortage of labor is something that we wanted to combat. And we wanted to do this by building basically robots. And we started with the painting robot, but we will later, or we plan to also expand into different areas after a while. But the painting robot is the first one. Let's see. Oh, that's too far. Sorry about this. Not used to this robot. To this laptop. Yeah. So basically, the idea is that we want to build robots not only to basically not at all to replace the worker. We want it to be a tool for the worker, and we want to assist them in doing their job. And the idea is that the robot does the stuff that is easily manageable, that basically just takes time and effort, and it doesn't really make any sense to have a person there to do this, while the painter is still needed in this case for like the finer stuff and to really get the job done and also to ensure the quality and so on. So while the robot itself is of course more, how do I say this? It's more like the quality of the robot is perfectly fine, of course, because in contrast to a worker, it's always doing the same thing. So it's very repeatable, which is also a benefit. So we use less paint, for example, as well. So this increases efficiency. Also, health risks are reduced because, of course, the painting dust is not that very good to breathe in. And so that can help with that. And of course, the bigger issue is also the ceiling stuff, because if you paint the ceilings, you always have to basically spray it in a very unergonomic way. And so this will also increase, hopefully, the health of workers in this area. Right, so the painting robot is the first product that we have, or that we are building right now, developing. Why is it doing this? 1 second. Okay. Yes. Oh, come on. I apologize for the technical issues here. This is not how it's normally going, but
No worries.
It's annoying me. I think now I have it. Okay, there we go. So the basic idea is right now we have the painting robot in development, but like I said, we want to expand in the future. So that means floor coating, which is, for example, for parking decks in like park houses, where you need to coat the floors with specific treatment so that it's more robust, or also sanding, which is basically what you need to do every time when you have a new building, that you need to sand the walls first, obviously. And all those types of jobs are just not good to do. Specifically, like sanding and the floor treatment is most of the time very uneconomic. And then, of course, the ceilings as well, like I said. And so we basically want to make tools to help with that. And in difference to other companies, because this is not the first, well, the only painting robot specifically on the market, we focus on a lightweight modular build with the idea that we want to be able to have this robot everywhere. So we made it so that it's modular, so you can take it apart and easily manage the parts, so you can transport it easier, and you can also bring it more easily in older buildings, for example, where the ceilings might not, or where the structural strength might be not as high as it is nowadays in parking decks, for example. Also, ease of use is very important to us. So we basically just want the painter to be able to take up the controller and just start. We don't want there to be any complicated process like scanning the room or anything. So this is all built into the robot. But of course, this means that the robot has to do this then himself. Yeah, so this was probably supposed to be a video, but you can see here what I said with the ceiling painting again. Right, I think I covered this basically. Yeah, here, so key features of the robot are on the right. Basically, we just use an airless system to pump the paint through a robot to the arm and then to the spray nozzle on the top of the arm, and the arm then moves along the wall. Unfortunately, the videos don't work because this is, like I said, technical difficulties. But basically, the arm moves up and down along the wall, while the base then moves perpendicular to the wall to basically cover everything. And we repeat that process until it's done. So the robot arm that we use specifically is self-developed completely from the ground up, because other companies use industrial arms, but those are heavy. And so we wanted a more lightweight solution. So we developed them basically ourselves. And of course, then we developed the software to basically control all of this, obviously, as well. And that is also where then the AI comes in. Let's see if there's, yeah, okay. So what we use the AI for mainly is for ease of use. So when you have a painting robot and you want to cover the walls, you of course don't want to cover everything, right? Like, for example, doors, windows, maybe heaters, you want to just not spray over. So what we do is we have 2 cameras on the arm that basically record the room, and that allows us to detect then via AI the obstacles on the walls, and basically avoid them completely, so that we don't waste paint on these areas. And that basically increases the efficiency. Also, the important thing is this makes it very easy to use, because as other than the obstacles on the wall, we also detect the ceiling height automatically, which means the painter is no longer required to first measure where everything is in the room, or make a complicated 3D scan, or have BIM ready for the whole building. They can just put the robot in there. The robot will automatically, while it's doing the process of spraying, it will just automatically find everything that it needs to avoid and put these parameters in. So that makes the use for the robot way easier for the painter then. Yeah, this is probably, yeah. So you see here the robot, how it's developed at the moment. And we're already working in a few projects, specifically right now in Germany, and in Switzerland we worked for a bit. But yeah, we are basically, it's already in use. Yeah, unfortunately, I'm not that much in business, so I can't tell you very much about this. But basically, right now we are in a rental phase, so we basically do not sell the robot right now. That is planned for the next year then. And right now, what we do is we basically rent the robot out, and we then basically just send the robot for a fixed amount per day. Right, here we see some other painting robots. I don't know if this is that interesting for this, to be honest. But basically, as you can see here, the benefit of our robot is basically the modularity and ease of use, which in comparison to all the others that are already here, there are a few more, but those are the main competitors that we have right now that are also in development. Yeah, this basically, yeah. So basically planned, like I said, expansion to other areas will be for 2026. For now, we focus on the painting robot and bringing that on the way completely. Yeah, basically that's the presentation right now. So I think I'm done with this.
Okay, perfect. Thank you very much, Vincent, for explaining us these incredible use cases related to robotics in this time. Let's continue with this webinar with our another guest, Mina Kolakar, who is co-founder and manager of innovation of Panto Health, which is a company dedicated to leverage AI and advanced analytics to revolutionize the maintenance on monitoring of critical infrastructures. Sorry for that. So please, Mina, whenever you want, you can introduce your use case.
Hello, do you hear me?
Yes, perfect.
So thank you very much for having me here. And yeah, the presentation I prepared is, yeah, and thank you, Vincent, for the nice presentation. We've been neighbor of Combotics from the beginning, and it's great to see the progress of your company from the time. And we hope that you continue going on the right track. So I'm just want to jump to the presentation, and yeah, please let me know if you have my slides.
Yes.
Yes.
Okay, great. So about me and my company. As it was mentioned, I'm one of the co-founders of Pantheals. We founded our company in 2020, and its idea is related to, improve the digitalization in railway infrastructures. Actually, we try to, narrow down to how we can add value in this industry. From the time that we wanted to start working on our idea, we were doing a market research and we understood that there is a huge pile of already collected data in rail industry, but there is a bottleneck. And the bottleneck was that this data was not converted to value. So the railway managers decided to, slow the pace down and um, make a break to just figure out how they can, make the value out of the collected data. It was the decision actually that the UK government decided. And what we are trying to do is that to, collect data, analyze data, and use it in a way that can bridges the gap or fill the gap between already available data and maintenance activities in the field. So the problem that we try to focus is the part of the infrastructure of the railways that is related to, providing electricity to the train. This device that is mounted on the roof of the e-trains and e-trams is called pantograph. It receives data and transfers it to the engine. So to avoid such accidents like that, the maintenance providers should, check the quality of the lines from time to time. It happens, for example, sometimes checking it every week, and for some other cases, they use the measurement devices and run it under the infrastructure once per 5 years. So they don't have access to the online data. So the problem is that most of the time they should do the maintenance very early, and sometimes it is too late that accidents such that happens. And all this process increase the cost that in general in Europe it is around 1 billion euro per year. And even worse than that, the delays of the trains and passengers, that it adds costs as well. If I want to summarize the levels of finding the problem in the line, so we can divide it to 4 categories. That the more mature one has more reliability and definitely more levels of collected data. The first one is visual inspection, that for example, maintenance teams goes during the night to the field and just check some specific profiling or maybe just very visible evidences of the defect on the line. The second level, which is very popular now, is that the maintenance team or manager of the infrastructure use an instrument like, for example, measurement train to collect specific data of the line from time to time. For high-speed trains, it happens in Germany once per 6 months, and for lines with lower level of traffic, so it is once per 2 years. And for most of the cities that they are using tram, it's once per 5 years. The third and fourth level, which is our company focus on, is real-time condition monitoring and predictive maintenance. When the monitoring device or measurement device will be installed on the regular train or regular tram and collects data continuously, we can say that it is real-time condition monitoring. And if in level steps, the collected data will be further analyzed and can be used to predict the early signs of defect detection. So it can be said that it is for predictive goals. And our company is located here. How we can do that? First, we collect data, analyze data, and at the end, answer to the requirements of the maintenance team or maybe our client. So we collect data from 3 channels. If the maintenance team have already collected some data, we insert it in our pipeline of data analysis. So here you can see it's a sample of the real data that our clients are using, different formats, very complicated to analyze, and just some specific people who are trained to deal with this data can use it. And unfortunately, after just the first check, so the data will be dumped and it will be used for, it will not be used for further application. But what we can do is that we collect this data. We try to, use the time series data modeling to define the, the trend of any change in the data, and then extract value out of it. The second channel is that if no data is already available, so we offer our data collector. We are offering different options for collecting different type of data, for example, acceleration or maybe visual figures of the contact between pantograph and the overhead lines. And besides that, we are even offering more precise devices that can estimate the profile or profilometry of the contact system with just even less than millimeters of precision by using laser sensors. So based on the requirement of our clients, we are offering different devices that can be installed in different parts of the train. And the third channel is our simulation model. So we have heard recently that there are different digital twin models of any different systems. So we are using, but most of them they are using some most of the time 3D models or some specific pictures of that system to generate a model. But in our wording, we cannot just say it as the digital twin of that system, because digital twin can predict or maybe analyze the behavior of that system as well. What we have done in our company, we developed a model that can simulate the interaction between the train, specifically pantograph of the train, and the infrastructure overhead line. So then we are capable of simulating different scenarios of the running train under the infrastructure, and besides that, we can simulate some defects. Therefore, we can say that if we call the other digital models even as model, the model that we have tried to develop has a kind of soul that can be used to analyze the behavior of the system. So yeah, I know I should go to this side. Okay. After we collected different type of data, we use AI models, machine learning models to analyze it, detect anomalies, and after that report it to our clients. So in my last slide, I showed that how we are doing it. And what we can offer to our client, we can categorize it to, answer of 3 main questions. Where is the problem underlying? What to do to solve the problem, and when is the best time to do the maintenance? How do we deliver it? So it's just a screenshot of our panel. It's a comprehensive one that the user can choose the time of the train travel, and yeah, even the hour of the train travel. Then besides that, they have some statistics of the train journey and statistics of the generated defects. So how do we show it? Actually, how does our system works? In my next slides, I want to show it to you. So the basic idea of our system is that we want to, do problem identification. I'm talking about identification because when we detect the early signs of a problem, we give an identity to that point. And when the trains travel as repeated. Oh, sorry. So we dedicate a specific value to that identity. And by comparing the values of the potential defects, then we can, see if a potential problem is getting worse or if it is in the safe margin. And then we can suggest or recommend on maintenance. So in this next slide, I want to just make a summary of what we are doing in our company.
Technology has transformed the world over the last 30 years. Cars, phones, computers, everything has changed. But what about overhead contact lines and pantographs? Even today, most companies still check their lines every 6 months to 2 years and record their data on paper, PDFs, spreadsheets, or old-fashioned software. This leads to massive delays, costly maintenance processes, and even bigger problems down the line. Panto Health is on a mission to modernize the entire process step by step. First, we import your current data into our panel, enhancing its readability and efficiency. Then we add our affordable and reliable devices into your system. These devices generate real-time monitoring data, which keeps you updated on any issues. The next step is to process this huge amount of data, extract insights from it, and create a digital twin of your network that helps you monitor all its points. By accessing our all-in-one interactive dashboard, you can view the list of abnormalities and easily navigate them on the map. If you require more specific details, click on a point for in-depth details, metrics, and related video, all at your fingertips in moments. With the Panto Health Simulation tool, embark on a 4-stage adventure. First, input basic information and instantly receive related results. Then, model within the system by adjusting pantographs and creating varied scenarios. And finally, receive a detailed report from the panel, which helps in selecting the optimal choice and minimizing real-world risks effortlessly. We provide you with a smart way to achieve the most optimal network with the lowest maintenance costs. Panto Health. Keep your railway system running at its best.
So now we go to the last part, which is related to the real cases. Here you see the setup of our system that we installed on a tram. So here is the video, and these are the sensors that are collecting acceleration signals. And then it's a device that collects and sends the rest of the data. Here is another sample that shows that how we need to customize our design based on the different designs of the train and pantograph. So how they are installed, the camera is installed here. So the accelerometers has to, monitor the interaction between a pantograph and the lines. Therefore, they should be as close as possible to the infrastructure and the contact point. And the other devices, like, for example, laser scanner or some cases, point cloud scanner can be installed up on the roof of the train as well. And then here is the sample of the collected data. So here's the view of our camera, and here's the sample of the collected acceleration data. And it is the view that the point cloud scanner sees for the, position of the contact wire that can be useful for generating the results such as zigzag, height, or sometimes the thickness of the contact wire. How we are using it? When one train passes a specific point and the sensors receive considerable shock, as I told you, we save the location of that specific point. And by at that specific time, we, based on our own analysis, we allocate a score to that specific point of the line that we call it health index of that specific point. When the tram or train travels repeats, so in some cases, that health index increase. So it means that the infrastructure is in a healthy situation, or maybe the data that we received from our sensor was noisy or had some problems. But whenever it shows that the chance of the defect or maybe the risk of the line is increasing, so the health index reduces. And it is all happening based on the repeated data. As I told you, condition monitoring, continuous condition monitoring of the interaction between the device, the pantograph, and the infrastructure. And here you can see a more, realistic of the results that we show to our clients. Here, based on the repeated travel of the tram, so the health index increase or decrease, and based on that, we can prioritize the maintenance or action requirements required from our clients or the user of our panel. Here you see the result of the three selected points that had a high risk of that were, detected as high risk points that one of my colleagues went to the field and with the maintenance team, they checked the situation of that line. So we highlighted one section insulator but with one specific design and one normal design section insulator and one point at the curve. So for that specific points, the vibration and specific lateral vibration had some, significant evidences that something is not normal there. So first, I go to the first point. The first point, I told you that it has a specific design. This is specific design that they call it ski rod, actually supports the pantograph to have a smooth contact with the contact wire. But when the train was traveling, so it faced an impact or a shock at the beginning of the contact point. And when my when my colleague went to the field, so he noticed that at the entrance, you can see here there are some veers, that it is because of the high speed of the tram and the impact that this rod faced. So we asked the maintenance colleague to adjust the height of this very two tiny wires. You cannot see, they are actually handling the weight of the section insulator. And yeah, okay, and it is the result. Here, the red result shows the signal before doing the small maintenance action, and the blue one shows the one after that. And we noticed that the features of the signals improved. The shocks, the level of shocks reduced, and the level of afterwards vibration reduced. That shows that the maintenance, we successfully could detect that point, and the maintenance was successful. So the second case was another section insulator that the train had a smooth travel when it was going to the section insulator, and at the when it was leaving the section insulator, there was a small step, as you can see here, that our accelerator had detected some impacts. And here, based on the scaleogram results, you can see that the energy of the exit part was, higher than the entrance. And the videos that we, recorded shows the same thing as well. So yeah, it shows that the train has a smooth entrance, but you can see at the exit, so there are some shocks. So, but unfortunately, the maintenance colleague of that specific part of the line was not with us that night, so this part was not repaired. The third part was a curve. So as I told you, we detected some abnormal vibration there. And when my colleagues went to the field, they noticed that the thickness of the contact wire, which is a very important factor for the safety of the line, is getting closer to the risky part. So our conclusion based on that inspection, and the result was that so there are some hard point or specific points of the line that can make a defect on the pantograph, and a defected pantograph can make a vicious cycle and damage the rest of the catenary and rest of the infrastructure as well. But definitely there should be a way to break this cycle. And what we are suggesting is to based on collecting continuous data. So we should not wait to see the evidences of the defects first and then take some maintenance action. We can detect the signs of the evidences of upcoming problem and allocate some human resources to fix it before an accident happens. And how it will generate the value here at the beginning, it shows that the defected points can decrease the lifetime of the infrastructure considerably. But if we make the all risky points, solve the problem of risky points, then the lifetime of the infrastructure as a whole increase. So yeah, it was all about our company, and I hope that you could, get what we are doing. And if you have any questions, I'm more than happy to answer.
Yeah. Perfect. Thank you so much, Mina, for showing us such a complete example of use AI case. Well, once this point has been discussed, we will move on to the round of questions, which will last, well, we got time, plenty of time, so please feel free to take this opportunity to engage with our speakers and ask any questions about the topic they explain, or maybe your point of view with these use cases. Feel free to participate in this interactive moment. And of course, if you want to share your point of view of any topic, please feel free to put your mic, or even if you want to type on the keyboard, and then we're going to see the chat.
I think I'm going to start to break the ice, okay? Thank you so much, Mina and Vicente. It was so very interesting use case of the application of AI. But I was thinking while I was listening to you, if you are thinking to apply your solution, or it is possible to apply your solution to other sectors, in the case of Combotics, and in other critical infrastructure, in the case of Panto Health.
So for now, it's basically just construction for us. That's also where the name Combotics comes from, construction in robotics. That's basically the idea. Of course, like I said, like different applications like sanding and so on are planned, but that's basically the same use case. We just change basically the end effect of the arm, right? So the basic idea will be the same. So robotics in general will, of course, be coming to different sectors, but for now, we personally as a company will focus on the construction side, and there we have diverse options to implement the robotics, of course, yes.
Okay, in your case, Mina?
That's a good question. Most
For
of the
example,
day,
in the aviation,
yeah.
the aviation, it will be possible to apply your solution?
Actually, we are on our kind of first or second pivot like right now, because we started with just focusing on the intercity trains, and we didn't have any focus on trams from the beginning, because our simulation software was more advanced for simulating the interaction between train and infrastructure for city lines. Still, we are focusing on that specific, I can say, problem, because there are not many people who are doing who are solving this problem here. So, and the market needs some focus at this specific niche situation. But if we can, achieve our vision, which is to, support the companies to smoother method of, or maybe smoother travel to digitalization, then we would like to extend our application to the rest part of the infrastructure as well, because we believe that electric trains or maybe trams are one of the most necessary part of, sustainable societies, and we are doing our best to support it. So we don't plan to switch it in like 2 years to another industry, for example, right now.
Okay, thank you so much.
Okay. Anyone has another question here? All right. Well, I think all being crystal clear. As our webinar comes to a close, I would like to thank all the speakers for their insightful presentations and all of our attendees for hearing them from and being here with us. And we hope you enjoyed this webinar. And remember, it will be published on our YouTube channel, after channel.
We have a question.
Definitely. Yeah, definitely, Maria. Do you want to type it down? Do you want to put your mic on?
Hello, good morning. I won't put my camera because I wasn't prepared for the video. But first of all, thank you very much for both presentations. And I found Panto Health's presentation particularly interesting. So I had a couple of questions to Mina. First of all, the sensors that you developed to gather data, were they developed in-house? And the second question is to compile all the information that has been gathered, in different kinds of formats like PDF or Excel or, whatever formats. It could be very, very labor intensive. So how do you deal with that? Have you created an algorithm to be able to import all of the information? Or I'm just curious to see how you've done that importing that data that has been gathered. Thank you.
Thank you very much, Maria. To second your last question, yes, you are right. First, we try to figure out if we can extract data from PDF. Is it possible or not? So, for example, extracting acceleration signals from a PDF it was a challenge. That we did it once. Yes, it worked, and you're completely true. We couldn't afford spending that much human resources on extracting data from PDF and Excel files. Then we switched to, using some customized agents based on the already available AI models, LLM models. Then it took about 1 or 2 months to customize. Then at the end, it was quite acceptable. And sorry, I forgot your first question. Could you please repeat it again?
Yes, sure. Okay, the first question was about the sensors that you featured to gather data. Was that developed in-house or did you partner with another company? And before you answer, maybe I should have, because I started with the questions and I didn't introduce myself. So just to let you know, I'm an R&D program manager at Multiverse Computing. We're based in northern Spain. And we specialize in quantum and quantum-inspired algorithms for AI, machine learning, optimization. So I think that we're very interested in the fields, especially in the use cases that you presented, and things like, for example, the LLM structures and the compression of those models, or the design of those models even, is something that we work with very closely. So thank you, Mina.
Thank you very much, Maria. About the sensors, we buy some of them out of the shelf, then customize it based on our needs. For example, the laser sensors or maybe the camera. We are just having some partners. But to design the whole structure that has to work as an IoT system, it is all done by us. And what you said about your activities and what you are doing in your research centers sounds very interesting. And we are looking for some research partner, business partner in different countries, because our industry is very, I mean, regulated, and regulation from each country, even each city is very different. So, and working on LLMs, an industrial application of LLMs is something recent in our company, and we are looking for some even research partners. So if you are interested, then we can have a chat afterwards.
Definitely. Thank you. I'll connect via LinkedIn. Thank you very
Okay.
much.
Looking forward to that. Thank you very much.
Well, thank you so much, Maria, for asking your questions and Mina for answering them. Is there anyone that want to type another question before we finish the webinar? Okay. So I'll take it as a no. So as I said before, thank you so much for joining us today. And we will looking forward to seeing you at our future events. And we will send you a questionnaire so we can share with us your opinion about these kinds of activities that we do on PTE Disruptive. And thank you so much for joining us. Have a good day, all of you.
Thank you to you all as well, and have a nice day. Bye.
Thank you.
Bye.
Thank you so much.
Bye.
Bye.